Discuss about the motional electromotive force. So production of electromotive force with motion of the conductor. So it is very interesting article for us to think about. We have studied that EMF according to the Faraday's law. हमने अभी तक जो पढ़ा है वो पढ़ा है हमने. EMF is equal to minus of a rate of change of magnetic flux. So this is what the extension of this article in a different way. So this is the figure 1. I will mark this as a figure number 1 from NCERT, and I would like to redraw this figure for your convenience in a three-dimensional mode. So for example, you are having a table-like arrangement. I would like to make it like this. So this is the same figure is in a different ways to plot it. So this is what the magnetic field is. This is magnetic field, which is uniform and time independent magnetic field. So we have a rectangular conductor. It is placed in this magnetic field like this. So this part is P and this part is Q, this part is R and this part is S. So this is P, Q, R, S. Okay. So this conductor is moving with some velocity B, and this is enclosing some area over here. This is the length of this part, and this part is just X. You can take as a width or length. It is all up to you. So this part is some M and N. So I have redrawn this figure for you. अब आप देखिए कि इसमें से जो ये कंडक्टर है, it's a conductor is free to move over here. Okay, this conductor PQ is free to move through this area with certain velocity B from towards the left. Okay, assume करिए कि that there is no loss of energy due to friction, कि friction की वजह से कोई energy loss नहीं हो रही है, and PQRS forms a closed circuit enclosing an area that changes as PQ will move. Okay, so it is placed in the uniform magnetic field B, which is particularly downward direction. This is moving in the uniform magnetic field, which is perpendicular to the plane. So see, as I said, this is perpendicular to the plane. This angle is 90 degree, and if the length of this RQ is, we consider that if this length is X and SR is some L, the magnetic field phi B, the flux produced, because both of this now area vector have the same angle, so we can take this flux now as it is. Flux is magnetic flux is given by B vector dot A vector, so which is BA cos theta, which further reduced to BA only. So here the magnetic flux now will be, you can write area in terms of B Lx in length and breadth. So as x is changing with time, so the rate of change of flux हमारे पास क्या आ जाएगा, as by definition, this is the equation number 1. So from equation 1 you can write, from equation 1 we have, so EMF is equal to minus of d upon dt of BLX. Okay, so here magnetic field is uniform, this length is not changing, so only x is changing as your rod is, the conductor is moving toward left, so x is continuously changing with the motion of the rod. So you can take B and L outside and you can write this part minus dx upon dt over here. So this is equal to the velocity, so here v is taken as minus dx upon dt. Okay, So EMF is now equal to BL time B. Okay, so this is your another equation, and this is the equation number some 3. So as this now electromotive force has different definitions. It is now BLB. So because of the term B involved over here, which represent the motion of the conductor in the magnetic field. So this is called the motional EMF. This is called motional EMF. Motional EMF. So we have to discuss now another base to find the motional EMF. So see carefully the same diagram and another way to produce the motional EMF. Consider करिए कि as it is possible to explain the motional EMF expression, this expression number 3, by invoking that the Lorentz force acting on the free charge. So this is a conductor, PQ is a conductor, so it has some free charge. So what will happen then? Let's see carefully. As this magnetic field is in the downward direction and the velocity vector is along minus x-axis, right? So you can write that the force on this charge, as this conductor has some free charge on it, so the force on this charge, there will be the force on the charge. Now we will see about the direction of the force. See carefully. मैं इसको वेक्टर डायग्राम से लिखता हूँ. So using vector algebra, देखिए आप ऐसा लिखेंगे the force on the charge, force on the charge, on the charge of conductor PQ of length L, PQ of length L is, फोर्स का फार्मूला क्या होता है? दिस इज इक्वल टू Q इंटू V क्रॉस B. सो यहाँ जो वेलोसिटी है, अब आप इसको यहाँ ऐसे वेक्टर डायग्राम में जो इस्तेमाल कर रहा हूँ वो मैं ऐसे लिख देता हूँ. So velocity is along this direction. So this is x-axis and this is minus x-axis. So this is y-axis and this is minus y-axis, and this is, as I've done it so many times, this is plus z-axis, this is minus z-axis. So now apply it over here. आप यहाँ लिख सकते हैं कि it is on either charge and then velocity is along minus x-axis. So I can write it as b of minus I cap. Okay, so change this vector like this, cross B, and then it is minus k cap. It is minus k cap. So minus minus से plus हो जाएगा, and Q B B, and this I cross K is minus j cap. So I will write. I would like to write that this force on the due to magnetic field on this, the charge on the conductor is along the negative y-axis. This force is force on this Fm. This force is BQB of minus j cap, means along negative bidirection. Negative bidirection. So it is along from P to Q, along P to Q. ये जो force होगा वो P से Q की ओर लगेगा. What does this mean? This means that the charge at P will move from P to Q. So the work done in moving the charge, the work done in moving the charge from P to Q is, work done क्या होगा? Force into displacement. This work done is equal to force, ये आपने किया, this force is equal to BQB into displacement. This is L. So what is EMF? Since the EMF is the work done per unit charge, since EMF is work done per unit charge, this is EMF is equal to work done per unit charge. This is BQB into L divided by Q. Q से Q cancel हो जाएगा, this is further BLB. So now here EMF is equal to BL time B. So this is once again the EMF. It is represented by equation number 4. So you see here that equation number 3 and 4 are same. So this means that the motional EMF could be created by the both base. इस तरीके से भी आप इसको कर सकते हैं. और there is another part of the same article is when it is not obvious that how an EMF is induced when the conductor is stationary and the magnetic field is changing. If conductor is stationary and magnetic field is changing, the fact that Faraday is verified by the numerous experiments Faraday has done. So in case of stationary conductor, the force on the charge is given by the Lorentz force. So it's another part of the article. I will choose this color. This is equal to F is equal to now charge and E plus this is V cross V. So this is V cross B. Okay. So now as this conductor is stationary, so the velocity is equal to 0. So you are left with the force is equal to Q time E vector. So now how this force is created in the conductor? So there is a question. So as velocity is 0, so thus any force on the charge must arises from the electric field E alone. Now this force arises from only electric field, right? So therefore, to explain the existence of induced EMF or induced current, we must assume that there is some time-varying magnetic field. There is some time-varying magnetic field because time-varying magnetic field is generating this electric field. But हम ये नहीं कह सकते, हम ये जल्दबाजी नहीं कर सकते. However, we hasten to add the electric field produced by the static electric charge. Let's have the different properties from those produced by the time-varying magnetic field. So this is what the beauty of the Faraday experiment is. हमने जैसे पहले पढ़ा कि हमने किया है कि जो कोई चार्ज जब मोशन में होता है तो वो फोर्स एक्सर्ट करता है स्टेशनरी मैग्नेट के ऊपर. ये हमने कर रखा है. और इसका उल्टा भी सही है कि एक बार मैग्नेट जब मोशन में हो सो वो भी एक फोर्स एक्सर्ट करता है स्टेशनरी चार्ज के ऊपर. सो यही एक फंडामेंटल सिग्निफिकेंस है फैराडे डिस्कवरी का. और ये बताता हमें कि एट द एंड हमें कह सकते हैं कि इलेक्ट्रिसिटी and magnetism. Electricity and magnetism are interrelated. Electricity and magnetism are interrelated. ये एक दूसरे के साथ जुड़े हुए हैं. Okay, एक दूसरे को इफेक्ट डालता है. So this is all about this video, and I would like to prepare the video for the problem as a separate video, so you can attempt the problem from the same video. So till then, goodbye.